Here we go. Hello, everyone, and welcome to the National Space Academy Takeover. We are taking over the National Space Centre's media channels all of this week, including their YouTube channel, so that we can host Q&A sessions with interesting people working in the space sector. My name's Kieran, and I'm the General Manager of the National Space Academy. I'm one of the hosts for this Takeover week, and right now I am joined by Robson Witts, who works for Oxford Space Systems and is a space apprentice. So hi, Robson, how are you doing?
Hello. Yes, I'm doing okay. Thanks for having me on here. It's lovely to be here. So I'll just do the quick intro about myself. So you already know my name because Kieran's already said that. So I am a fourth year apprentice, or I currently am a fourth year apprentice at Oxford Space Systems. We are currently based in Harwell Science Cluster. Just look on Google Maps for the diamond light, the big donut thing, and you'll find Oxford Space Systems quite easily. So what do I do? Well, right now I am sort of responsible for the assembly and test of some projects. So I've actually been given some projects that I'm working on. Some of these I'm actually working above some people, so I've got some people working for me, which is really exciting. And mostly I'm just tasked with keeping schedules and making sure things are turned in on time, which is incredibly important because it's quite easy for days to turn into weeks and months on certain activities for those projects, really. So it's good to have somebody who keeps that stuff online. But in some other places that I work, I do quite a lot of assembly of space hardware. I'm actually proud enough to have something that I've built in space at the moment. It's in orbit. It's only a little thing. It's nothing too spectacular, but it's still something in space that I've touched. And also go into certain test facilities to verify some of these things that I've built. Really, I've built anything from small models just to test if a certain concept will work, to all the way through to those flight projects, really, that we'll be flying. So very expensive things to be working on. I definitely don't want to be dropping that sort of stuff. And yeah, that's pretty much what I do. I'm sure there'll be more specifics, but I don't want to be here all day.
Great stuff, Robson. That's a great introduction. I think you said you've worked on building something or making something that's in space already in your apprenticeship. Yes. And then you downplayed it and said it's just a small thing. But I feel like it's still a massive achievement. Can you explain to us the device that you're working on? I'm guessing it's on a satellite.
Yes, so it's on a small satellite called CubeSat. So just for the people who don't know, you ever get some article or something like that says like Amazon or Facebook has like 3,000 satellites in orbit? Well, they're not massive sort of satellites that you would normally think. They're small satellites about the size of your average lunchbox, really, and they're called CubeSats. And what they do is they put loads of these on rockets or launch platforms, as they're called. So you can have loads of them on there, and then they go up into space, and then all those little satellites go their separate ways, individually controlled by different companies and whatnot, really. And all that I made was a small helical antenna. It's the one that's on our website. It's just like a small spring, basically, that comes out of a box, and then that functions as just a antenna, basically, for that satellite. So yeah.
Okay. So you used the word helical antenna. So helical is a fancy way of saying it's spring-like shape.
It's a right? Spring, yes. Yes. So it's one of the things that we do.
Okay. So this is Oxford Space Systems is very good at these. I guess so. You have the spring that packs down really small, and that's what Oxford Space Systems is really good at. Is that right?
Yes, yes. So I probably didn't explain that too well, but Oxford Space Systems specializes in deployable space structures. Is sort of like the big thing. So that's antennas and satellite dishes and booms or anything else, really, that that starts in a small space in one of these launch vehicles, and then when it is in space, it then deploys into something larger, or whatever the company that hires us wants that thing to do.
So yeah, so you're managing to pack this equipment into a really small parcel, goes into space, and then it can get bigger because space is at a premium on those launches, isn't it?
Yes, space
Yeah.
and weight is a premium, really. I think 1 kilogram is something like 25 grand to send up. So shaving weight off is really important. But the tricky part is the customer doesn't want that thing to skimp out on size. So that's why they start small and then become bigger.
There's so many questions that I could start to take this
Yes.
in the direction of, but I'll start with one. It's been mentioned in the comments, and it ties in with something I was thinking about. So we've got Mike from the Institute for Research in Schools, and also sometimes works with the National Space Academy. Hello, Mike. Asking about how do you cope with the stress and responsibility of working to deadlines, and how did it feel being the person in charge for the first time? Because you've said you've started to be in charge a little bit.
That's that's a fun one. So when you are working under those tight deadlines where your project manager is breathing down your neck saying everything needs to be done yesterday, you take it each day, each hour. What can you be doing? How does everything kind of fit? And one thing that I have actually had to do for a project where I needed to finish it in a week or something like that, because the assembly was taking too long, and it was back before Christmas, so people were starting to go on holiday, and it was in tests, something like the 4th of January, so it had to be done. I just wrote everything on a whiteboard so that everybody who could help me, or anybody who could sort of see it, so my manager could see it, everyone could see it, just what tasks needed to happen every week, and when I needed people to come in, because we have quite a few people working from home, and in some stages of the assembly, because this was a engineering model, so it's sort of flight but not quite there. So I needed some people to come in and approve certain stages really of the assembly to make sure that it meets requirements. And so I had to mark which days and what times really, when do I need these people exactly? And then I got everyone basically to take a look at it, and anybody who had sort of any points for improvement or any sort of efficiency notes that could happen, then that was sort of predetermined, and then we just skated through the next week pretty easily. So that's one way that I've managed those kinds of things. There are other times when simply something goes wrong and it no longer is in your control. For example, I do the assembly and test of things, but suddenly a RF engineer says that something is wrong with the assembly and it needs to go through some kind of simulation. I can't do that, so I need to just sort of detach myself from it so that I'm not stressing, and then the second it comes back to me, I then work as efficiently as I can to make up for lost time.
So it sounds like you have to work really collaboratively with lots of other people. When you were describing
Yes.
the whiteboard, and that's so many other people, and then you specified some different engineers. So is Oxford Space Systems, is that a big organization? Are there lots of people that you work with?
So I'd say it's a small medium enterprise. It's somewhere between 50 and 55 people, I think.
Oh, right.
This particular example that I was talking about just has a small team of basically one of each sort of discipline, really. One designer, one project manager, one RF engineer, and me. So
then
it's quite a
again,
small team.
that is quite a lot of responsibility on your shoulders. And when you talked just a little while ago about the cost of sending things to space, and I imagine that some of the materials that you're working with maybe could be quite expensive as well. So what's that feeling of responsibility like, knowing that you've got that pressure and that you have to get things right because they've got to work in space?
Yeah, that's not too tricky, because a lot of the when you say things can be expensive, most of the time it's a combination of the material that you've made a part out of and the cost of the machining in general, really. of that part and its tolerances and things like that. So anything really that could go wrong has already been done to the part itself. As long as you don't break it, then you can't really go wrong. Yeah. Yeah, so
Okay.
I think that's sort of
Yeah, that makes sense to me. So you will have tested it, you will have machined it here on Earth, and by the time it's going to space, you know that it,
yeah,
unless
it's
something drastic happens.
already known that should work.
Yeah. Mike's also asked about what kind of materials are you talking about when you talk about the materials that you're working with? So we're guessing metals, metal alloys, things like that.
You would probably be wrong there.
Oh, right. Okay.
Yes. So the closest thing that we have to metal that we use for our things is just aluminium, basic aluminium. It's got a special coating on it to stop it from corroding with atomic oxygen erosion and things like that. But most of the stuff that we do is plastics. So we use quite a lot of plastics like PEEK and Ultem because they're quite resistant to radiation and atomic oxygen, which you get in space that are quite harmful to plastics. They tend to go a little bit brittle when they're exposed to space for an extended time. Plus, you've got weird temperatures up in space as well. As for things like helical antennas or some of our larger structures, so helical antennas tend to use forms of glass fiber for the structure. There is one that is a 2-meter long helix that is made with spring steel. But some of the other larger projects using a lot of carbon fiber at the moment. You mentioned at one point the thing that Shafali used, that sort of tape, that's carbon fiber molded in a specific way that it has essentially 2 shapes that it's happy to be in.
And it switches between one and the other. So that's quite clever materials. And it's interesting. As soon as you said, oh, well, plastics, actually, I guess they're lighter as well. And then you talk about the radiation risk.
Yes.
I've got a couple more questions in the comments, but I want to ask a couple of the questions that we had beforehand. Some of them submitted by our space engineering students who obviously are very interested in the work that you do because it relates to that. So a bit about what it's like being an apprentice, because it's not a route that everybody knows about. So before I ask their questions, how did you find out about the apprenticeship? And what were you looking for when you found it?
Yeah, so just go back in time a bit. You're going to make me sound really old here, but when I was at secondary school, I did look at apprenticeships a little bit. I sort of had heard about them mainly because one of my cousins had done an apprenticeship for his job. And I tried getting one, but the interview went really bad. I wired a plug to be lethal, and it didn't go very well. And I didn't really know what it was I wanted to do either, because when you say I want to be an engineering person, I want to go do an apprenticeship in engineering, it's like, okay, where? it's where do you want to do that? What do you want to be doing? It's saying something for engineering is just such a large spectrum really to find something. So it was incredibly difficult for me. So what I ended up doing is I ended up going to college and doing a extended level 3 diploma in engineering. But so I had an extra 2 years basically. So when I was 18, then I found that which I sort of knew a little bit what kind of apprenticeships I wanted to do. I tried using different agencies to get apprenticeships, but eventually I did come across Oxford Space Systems through my college that I then applied to and then got an interview for, and then well, I'm here now. So that's how I got into that.
Okay, it's great that you found that pathway, and there's nothing wrong with if things don't work out with that apprenticeship that you applied for, then going back and going, well, how can you upskill and make it more likely to get the next one?
And it's much better to jump at something that you're passionate about, because one, it's easier to get in because they can see that in the interview, and also because, well, you'll be happier really if you're working on something that you enjoy.
That is great advice, and it's very true. Matthew, one of our space engineers, has asked, what are the benefits to doing an apprenticeship rather than going to university?
I don't like saying that one is better than the other.
Okay, fair enough.
They are different. and where they are different might apply to how you like to learn differently. I went for an apprenticeship because I like learning physically. I like working with materials, doing jobs, and making my own mistakes. I don't like working through textbooks and other bits like that. There are plenty of reasons to go to uni, and there are plenty of reasons to go for an apprenticeship. But if you want, the main difference is just money. That's what always gets people is you're not earning a lot. You're not going to be a billionaire overnight by doing an apprenticeship, but you do earn money, and you don't have to worry about tuition fees or debts or anything along those lines. But there are other advantages for going to uni as well. With apprenticeships, you also get the experience as well.
Yeah, that's a really good answer. I really like the way that you said you weren't going to say one is better than the other, but
no, I don't like saying that.
Yeah, but it's obvious that this seems to be really working out for you. You seem to be really enjoying where you are now, and that type of learning suits you. I think some university courses do try to have more of a hands-on element, but that debt thing and the fees, I think, is something that young people do think about. And maybe those of it, so when I went to university, it's a long time ago now, I was only paying that first level of fees, and I don't know what I would think about that. So one of the things that I worry about is that people's first impression of apprentices might be that is somehow a more junior route into the sector, but it sounds like it's led to responsibility for you.
Yeah, it's a more gradual route, I would say. You kind of jump ahead if you do university, and what you'll I think they call it the dead zone, really. When you come out of college or secondary school, you've got like a level 2, level 3 qualification. When you go to like bachelor's and master's degrees, I think they're around level 5, level 6. So you're missing the level 4, really, which is normally covered by a HNC or HND. And some apprenticeships will cover you through level 4, but they'll also give you that couple of years of experience that you need. And that mainly helps with you getting a job. I mean, it's perfectly fine to do an apprenticeship for 4 years and then jump onto uni. You'll take longer, but it'll be definitely easier to get a job afterwards. I mean, I've heard plenty of stories of people going to uni and then struggling for a job because they're overqualified for what it is they want to do.
Yeah, and it can be very competitive for graduates, and yeah, it can also be the first time you're out of education for some people, so it's a bit of a strange experience. It's interesting what you said there about HNCs and HNDs, and you yourself said that you went back and did the BTEC qualification. That's right.
Yes, the level 3 diploma.
And I think a lot of young people, and we work with them in the National Space Academy, often think that career pathways are a straight line. But even in your career so far, it sounds like you wouldn't necessarily say, well, now it might look like a straight line, but you have definitely kind of adapted to things as you've gone along, with that first application for an apprenticeship not going your way.
Yeah.
So what kind of skills, so this has come from Evan, who's one of our space engineering students, what kind of skills do you need for an apprenticeship like yours at the start?
What skills do you need? Be more specific. Is this for getting into an apprenticeship or actually doing the job?
I think let's go with what skills do you need? Yeah, let's start with for getting an apprenticeship in an area like yours.
Area like mine. Okay. You definitely need an attention to detail when it comes to apprentices. Most of the time, if you can get to an interview, once you get to the sort of talking part of the interview, that's kind of down to your personality, really. Just be normal, be just happy to be there. Definitely research your company before going to that interview, because they always ask you questions on the company. That's quite a big no-no if somebody goes in and goes, oh, so what do you know about the company? I don't know, I just looked at the paycheck that was coming my way. That's not a particularly good way to start the interview. So once you've cleared that bit, you're pretty much fine. But one thing that you will be weighed up against your competitors, because that's what they are. They're not colleagues yet, they're competitors. It doesn't matter how big a company you're going for, there will be some element of competition. You're given like little tests to do, and they'll vary for different different jobs, but one of the most common ones is the wire bend test, that is quite easy to see on Google Images if you want to know what it looks like. But it's just like a dexterity measure basically, and there's different points that you can score for based on how well you bend the wire into shape. But there are some others that we do. One of them we do is like a small structure made out of this test extrusion that we use to make a lot of our jigs and fixtures and things like that. And going back to the attention to detail, one of the points that we make in there to catch people out is wear gloves before doing it. And normally that takes about 50% of the applicants away just because they didn't put gloves on. So really pay attention to how to do things, and try not to get too nervous during the interviews, because then you can't think straight and things like that will catch you out. But again, don't be too nervous as well, trying to find the point in everything. So it's kind of a weird mixture of being comfortable but not being too cautious either.
It's kind of like keeping a cool head, because of course you're going to be nervous for an interview, but then taking a breath and working out, okay, if I was just doing this for my job, what would I start with? I would start by putting my gloves on.
Yes, kind of exactly, and that's what we're looking for.
I am just sat here desperately trying to think, like, would I remember to do that, or would I be the kind of person who'd charge in and be like, let me try.
It's written down on your instructions, so if you miss it, it's your fault.
Right. Okay. I'd like to think I would miss those instructions. So that's you have these hands-on skills as well as the technical understanding by the sounds of it from the work that you're doing.
Yes. So it's kind of just a really broad mixture really of technical understanding and then having the hands-on skills that you need.
And you've already answered one of my other questions, which was, is there a lot of competition for roles like yours? And you said earlier about that there'll be other people who are competing for the same role.
Yeah. And it really depends on the company as well. Like I know Mini gets something like 500 people applying there. Really, that was when I was in college. So it's probably a lot more now. But there will be people putting their CV in everywhere really that they can possibly get to. So there is a lot of competition for these kinds of jobs.
And I think in the space sector, apprenticeships is still the less well-trodden path. The more direct route is the graduate pathway, which is why it's great to hear from someone like yourself. I'd like to talk a bit more about the projects that you've worked on and maybe some of the other skills. So we talked about the manual dexterity and the engineering understanding that you've developed. You were talking earlier about the project that you really needed to get on track, your experience with the whiteboard. So what kind of skills have you developed that are more along the project management, or perhaps not so much the engineering, the hands-on engineering skills, but sometimes people use the phrase soft skills, but I'm not sure if I'm a massive fan of that phrase.
So are you talking about the how we actually make the antennas now?
A bit more about how you get that teamwork going.
Yes, how you get the teamwork going. It's well, when I've come to project manage things like that, I don't want to use the term project manage because that's like, that's the project manager's job. I look after the assemblies. It's a bit more my pay grade really. But what I do is I try to maintain the critical path of the project. Just look that up. It's basically the minimum time it takes to complete a project, and it kind of shows how each task knocks on to the next one really, and I just look after that really. So if I need something done, I say that needs to be done by this time and help just maintain that, and then if somebody says, oh yeah, I need something else to help me do that, then yes, we go and we feed that back up the chain to make sure that we can complete what we need to complete when the higher ups want that finished. So it's mainly just communication, making sure everybody has a clear understanding, and managing people's expectations as well. I have flinched quite a lot of project managers when they've said, "Oh yeah, when's this thing going to be done?" And I've always said, "Oh yeah, it'll be done in a couple of days." And they're like, "No, it needs to be done tomorrow." For example, it's like, well, I don't want to say that and then delay it.
You want to, yeah, managing expectations is that key phrase there.
Yes.
And I guess you then have to have quite good people skills, because if your project manager wants it done, yesterday, and you know that it's going to take at least half a day, and you want a bit of kind of buffer time, you've got to be able to persuade them a little bit. Is that right?
Yeah, and it's just making sure that people are trying their best, and if you don't think people are trying their best, then obviously you need to ask them again, until they do something like say, "No, I don't want to do this," and it's like, okay, why? Then you start getting into the tougher conversations of asking, why does somebody not want to do that? But I haven't had to deal with that just yet, so that's been fine by me. But mainly just communicating things and saying to the people that you're giving those tasks, saying that it is important that it is done, and then also, because you can see the schedule, telling them why it is important as well tends to help a lot. So it gives them a sense that what they're doing is important, and then they motivate themselves to get it done.
Because you're all working together on this project. Great stuff. So you're presumably working on a couple of projects right now. Can you tell us about any of them? I know you might not be able to, because some of the technology, I guess, Oxford Space Systems wants to keep under its hat.
Yeah. So some of the ones are currently under development at the moment, so I won't shed too many details on them. But most of the ones that I've been working on at the moment have been smaller projects, mainly following the helical antenna design. So I was mainly looking after one of those for, well, since I came back from furlough on August last year. Really, was looking after the assembly and test of that project, really. And it's still got some tests now, really, that it's going through. But yeah, working quite closely with the designers and making sure that they're making things that we can produce for them, and also making sure that we can keep to the schedules that have been set for us. So one of them that I have made is for another helical project. It's, can't remember the exact size of it, but it deploys to a 2-meter helix. So it's quite spectacular when that one comes out. And that was the first of its kind. So I've been looking after boring stuff like a lot of the paperwork, but it is important that people know how to do that. And day to day, a lot of my tasks working with these projects are working within the quality system that we have, which is quite difficult to do, because you need to know what's within your control and what you need to pass on. So it then gets a little bit more difficult. It's not as easy as just filling out forms and stuff like that. Sometimes you're actually making the forms that people need to be doing, and then you either get the pleasure of assembling it yourself or giving it to somebody else and knowing that they'll be okay with it. If nobody gives you an awkward phone call at lunchtime saying that they're struggling with something and they don't know what to do, then you can have a happy day, really, because you know that you've done your job correctly.
And you also know that you're working on really new technology. So
yes,
what you just described is a system that's never been designed or built or quality controlled as you were doing before, and you're working on something brand new. How does that feel?
It's kind of scary, but you make sure that you have like a logical approach to everything. You eliminate everything that can possibly worry you, and you manage the things that do. And that's down a lot of the time to people a lot smarter than me, a lot of the designers and analysts that make sure that what we're making is going to actually work. So yeah, so I didn't have too much concern with that. I only get concerned structurally on some of the fixings that people like to use, and I can sometimes question, is that the best way to do that? And then when we say yes because of X, Y, and Z, and it's like, okay, then that's fine.
That's the attention to detail that you're talking about that you clearly have.
Yes.
Robson, we're about to come to the end. So I've just got 2 questions I'd like to squeeze in. The first one is, I think you're in the fourth year of your apprenticeship. Does
Yes.
that mean that you're coming to the end soon? And so what will you do next?
What will I do next? I will stay with my company, really, and keep working and moving up as I have done with my apprenticeship.
Brilliant. That's great to know. And hopefully, well, in future years, you can come back and tell us how you get on further on in Oxford Space Systems, and
yes,
maybe come and speak to
really
some of our
nice.
space engineers. And the last thing I would like to say, and you've given some advice before in some of your answers, but what advice would you give to a young person who knows that they want to work in the space sector, or particularly in space engineering, if you'd rather be specific?
Okay, so what will I tell somebody young who wants to do that? Definitely pick something that you really want to do. Try your hardest to find what is bad about the apprenticeship that you'll be doing, and nothing will ever disappoint you then. So always try and find something you can be passionate about and that you're going to enjoy, because there will be times in your apprenticeship where you will think, was this the best idea? And then when you get to look back on what you've done, you'll then go, yes, that was the best decision, I should have kept it. So you got to make sure that you can see far enough ahead that you can see where you want to be, and then match that to the apprenticeship that you want to do.
That's brilliant. Thank you so much, Robson. That was great advice. Thanks for taking the time to talk to us. And to those of you who are watching, remember you can see more of these Q&As tomorrow. It's our last day of the takeover, on the National Space Centre's YouTube channel. And you can get in touch with the National Space Academy on Twitter at UK Space Academy. I think you can also find out about Oxford Space Systems using social media as well, and maybe see some videos of some of those deployable technology that Robson was talking about. You can also go to the National Space Academy website, which is nationalspaceacademy.org, where you can find a form to contact us, send us your space careers questions, and we may be able to put them to our other guests tomorrow. All that remains for me to say is thanks again, Robson, for talking to us, and we wish you all the best with the rest of your apprenticeship, and whichever devices you're now working on, we wish you all the best with them. I hope people are putting the right fastenings on and doing as they should. Thanks a lot.
Yes, perfect. Thank you, guys. Thanks.
Thanks, everyone. And just... Brilliant. Right, we're off loud. I very nearly